Welcome to qnawire.
The first step of this problem is to find x of t for both paths. And by paths, I mean the first path being a positive slope for the velocity and the second path being a sharp negative slope for velocity. To do this, I'm going to find the slope of both lines. So the slope of the first part is y2 minus y1 over x2 minus x1, or 12 minus 4 over 10 minus 0. I'm just reading off of the graph. This is equal to 4/5. The y-intercept of the first path is equal to 4. Thus, the velocity of the first path with respect to time is equal to 0.8 times t plus 4. Since the second path is hard to determine the y-intercept off of, we have to use something called point slope form. We're still going to need the slope of the second path. So slope of 2 is y2 minus y1, which in this case is 0 minus 12 over 12 minus 10 being x2 minus x1. That ends up being negative 6. So now we have to use point slope form, which is y minus y1 is equal to m x minus x1. Given an m and given a point on the line, this will give us the equation of that line. And at the end, I'll convert y to v2 and x to t, because those are the proper names in the problem. So the point I'm going to use for y1 is 0. M is negative 6. And the x value assigned with y1 being 0 is 12. So this simplifies to v2 of t, substituting in v2 for y and t for x, negative 6t plus 72. So now that we have the two equations for v, we can start to actually solve the problem. We're going to want to get x1 of t, and we do this by integrating v1 of t. And so I'm just going to pull the 0.8 out of the integral. And then we also have the other part, which is just a constant 4, but we still have to integrate it. And when we do this out, we get 0.8 t squared over 2, just doing the reverse power law, plus 4t. Similarly, we're going to find x2 of t. So we get negative 6 times the integral of t dt plus the integral of 72 dt. And doing this out gives 0.8 t squared, or messed up there. It's negative 6 t squared over 2 plus 72t. Now, ultimately, we want to know the distance that this thing travels. And so the distance along path 1 that it travels is going to be equal to x1, which is our path for the first one, evaluated at the far end point of the first path, which is at time is equal to 10. Then we're going to subtract that by the original x1, and it starts out at 0. Plugging 10 in here gives 80 minus 0. And so along the first path, it travels 80 meters. The distance along the second path is equal to x2 of 12. In this case, I'm using the rightmost point of the second path. And then the leftmost point of the second path is at 10. So I have that. Plugging these two values into this for t and simplifying gives 432 minus 420, which is equal to 12 meters. So the total distance is equal to the sum of the two, which is 92 meters. But the total displacement is actually smaller because this 12 meters, because the velocity had a negative slope, it was moving the opposite direction. So we need to do 80 minus 12. We moved 80 meters to the right and then 12 meters back to the left. This didn't affect the total distance because it's all just distance, but displacement, you have to subtract them. So total displacement is equal to the difference. So it's 68 meters. That's parts A and B. In part C, we have to plot the acceleration with respect to time. And so if I create my axes, this is time, this is acceleration. I'm going to extend this down a bit. We know from time from 0 to 10 seconds, let's say this is 10 seconds, we have a velocity that is positive and is a little shallower. And in fact, if I can find it here, the slope is 4/5. And since the acceleration is the derivative of velocity and the slope of this velocity line is 4/5, the acceleration is actually just 4/5. Positive 4/5 up until here. So this is 4/5. At this point, the object turns around and moves back the other way. The slope of the second part is -6, and so we know the acceleration must be -6. So I'm going to go way down here. So let's say that's -6. Then from 10 to 12, it'll be a solid line just like that until we get to 12. And so that is the plot of acceleration versus time.